So some of these parent functions are functions that we've talked about before and some that we have not. But what we'll do then is eventually we will be doing transformations of these parent functions. So the first thing I wanted to do is just get down their general shape. So I'm going to jump around just a little bit. So if I'm going too quickly or you get lost, just please let me know. But copy this down on your sheet so that you have a copy of all of them. But I'm going to start with, I'm going to skip the first one and start with just f of x equals x. And so think of that as like in slope-intercept form, y equals mx plus b. Our slope is 1 and our y-intercept is 0. So without making a chart, and I'm not going to bother making a chart, that line is going to look just like that. It's a y-intercept of 0 and has a slope of 1. So the domain is going to be all real numbers. So again, when we write that in interval notation, it's going to be from -infinity to infinity. And the range, when we squish that onto the y-axis, is also all real numbers, or -infinity to infinity. So that is a linear function, meaning it makes a line. Well, the next one going down into the left here is a parabola or a quadratic. So I'm just going to write that it is a quadratic on there. And so there are some really important parts of a quadratic. The most important point is the turning point, or the minimum or maximum, where it changes direction. So if it's just x squared, then that turning point is at the origin, so I'll put a dot there. And then the next part is, how wide is it? Is it real wide like this? Is it real skinny like this? You know, what does it look like? So the way we can get that is from that quadratic is, from our vertex, if we go over 1 and up 1, and then over 1 and up 3. So we went over 1, up 1, over 1, up 3, and then do that in both directions because it's going to be symmetric about the y-axis. That parabola will look like that. So it has a domain of all real numbers, domain from -infinity to infinity, but the range is not all real numbers. Okay, because the graph doesn't exist down here. So the range is everything from bracket 0 to infinity, parentheses. Because if you squish that onto the y-axis, everything from 0 up would be covered up.
Can you go back up to the first one?
Yep.
Like in the top right?
Yep. So that's linear, and it has a y-intercept of 0, so it goes to the origin, and it has a slope of 1. So I'm just trying to give you guys a couple of key points to put down. You know, we don't need to make a whole chart of a bunch of different values, but a couple of key important values. So for the x to the third, that is a cubic. Here's what it looks like. Okay, that cubic function also goes through the origin. And we also go over 1 and up 1, just like the quadratic. However, when we go over 1 to the left, we go down 1, and the cubic graph looks like that. It kind of looks like you took a parabola, although it's not exactly parabolic, but kind of looks like you took a parabola and just flipped over that left-hand side of it. Okay, that's the basic shape. And so its domain is all real numbers. So from negative infinity to infinity. And its range is also all real numbers from negative infinity to infinity. All right, if I'm going too quickly, just ask me to slow down, please. I'll just keep rolling. Because the next ones are ones that you're probably not as familiar with. So the square root of x, okay, I'm gonna call it the square root function. The square root function also goes to the origin, kind of starts at the origin. And we go over 1 and up 1. And that graph looks like that. So what it actually is, it's actually a parabola on its side, but not the bottom half of it, or else it wouldn't be a function, right? It wouldn't pass the vertical line test. So it's like half a parabola on its side. And so the domain is going to be everything from inclusive of 0 to infinity. And the range will be the same thing, inclusive everything from 0 to infinity. All right, so we did the square roots. We now should do the cube root. So the next one is the cube root function. Zero, zero, again, as a point. I mean, just think about if you plug a 0 in for x, if your input is 0, your output will be 0. And again, we're going to go over 1 and up 1. But now we're going to go to the left 1 and down 1. And the cube root function has a basic shape like that. It's kind of like x cubed, you know, twisted on its side. And so its domain will be all real numbers, and its range will be all real numbers. So its domain is from negative infinity to infinity, and its range is from negative infinity to infinity. So are there any questions on those yet?
Can you just stay on that screen for a second?
Yeah. Yeah, I'm just kind of letting people get caught up. I know some of you guys are writing feverishly, so. So while you're writing, again, where we're going to head with this is we're going to say, all right, these are our basic shapes. Now let's manipulate them. Let's, move them. What moves the graph up? What moves the graph down or to the left or to the right? And so we'll be doing manipulations of those graphs. But obviously, it doesn't do you any good to know the manipulations if we don't know the parent functions first, if we don't have an idea of what they look like. All right, I'm going to go on to the next one, which is the absolute value of x. And you guys, I think, are pretty familiar with this. I'm going to write down absolute value. That's the one that looks like a V. So absolute value looks like that. It actually is just that first one we did, that linear function. It's really just that guy with the bottom half reflected over the x-axis, because those are because the outputs are positive and not negative. So it has a domain of all real numbers, so from negative infinity to infinity. And it has a range from 0 to infinity. I am also recording this, and I'll leave it on there for you guys if you ever want to look back at it. All right, our next one will be 1 over x. So this is the reciprocal function. Here's what that guy looks like. It's kind of a crazy shape. So if you went over 1 and up 1 and put a dot there, and to the left 1 and down 1 and put a dot there, not through 0, 0. Because look at the function itself. You can't have an input of 0. It's undefined because you'd have 1 divided by 0. So what that function actually looks like is it has what's called a vertical asymptote and a horizontal asymptote on both parts of it. Now, I'm going to erase these green lines in a second, but what that means is it gets infinitely close to this green line, but never touches it. And it gets infinitely close to this green line, but it never touches it. So the domain is almost all real numbers, except 0. Remember, we can't plug into there. So the domain is going to be everything except for 0. So looking at this domain, if I want to write everything except for 0, we write that negative infinity to 0, exclusive, then union from 0 to infinity. The range is going to be the same thing, by the way. So the range is also everything except for 0. So from negative infinity to 0, and from 0 to infinity.
Wait, can you zoom in on that one again?
Yeah, this one?
Yeah.
Yep. All right, so those functions are what we're going to do a lot of transformations with. I'm going to give you a couple of more down here, but these guys we haven't talked much about, or you may not have talked about them at all in your previous classes, but I'm just going to give you the basic shapes and not get into them too much. So 2 to the x, that is the exponential function. And all exponential functions have the same basic shape. They go through 0, 1, and they have this J shape. And I'm not going to write down domain and range. We can talk about that stuff later. I'm just going to write down the basic shapes. This is a log function. Here's what a log function looks. It looks a lot like this guy, but like flipped over this diagonal line. So it looks like this. It goes through 1, 0, and looks something like that. So the nice thing is e to the x is also an exponential function. That's going to look the same way. E to the x goes through 0, 1. Same basic shape. We'll get much more into specifics later. And ln x, that actually means the natural log, which at this point probably doesn't mean a lot to you, but it's just another log function like we were just looking at. So I'm just going to give you the basic shape of it. Okay, and then we have the sine graph and the cosine graph. Those are squiggles. So for right now, here's all I want you to write for the sine graph. The sine graph, it has a top here at 1 and a bottom like at -1. I'm going to get rid of those, but it goes through the origin, goes up to 1, comes down to -1, goes up to 1, comes down to -1. That's what a sine graph looks like. It's just a wiggle going from +1 to -1, +1 to -1. And I guess I should write that sine graph. It's S-I-N-E, even though we don't write the E. And the next one is the cosine graph. So C-O-S-I-N-E. Looks very similar to the sine graph, except it doesn't start at the origin. It starts up here at +1, then goes down to -1, then goes up to +1, then goes down to -1. And they both actually continue forever to the right and forever to the left. So their domain is all real numbers for both of them. But I'll fill in domains and ranges and quite a bit later. So I'm going to recap and let me know if you have questions while I'm doing that. Oh, we didn't do the first one. Let's do that. If you just have a number, that is just a constant number, or called the constant function. Because that means just for every input, the output is 3. So it's just a horizontal line at whatever the number is, in this case 3. That line is supposed to be horizontal. So it's just a horizontal line. Our domain is everything from, it's all real numbers from -infinity to infinity. And our range is just the number 3. Okay, so looking at those first 4, we had the constant, the linear, the quadratic, and the cubic. You know, some important things to point out, like the quadratic, its domain is all real numbers, but its range is only from 0 to infinity, inclusive of 0, because we can't get an output of 0. Okay, and a cubic function goes both up and down, and that's because you can take the cube root of negative numbers. So when you plug in negative numbers, you get negative outputs. We then had the square roots and the cube roots. So the square roots domain was from 0 to infinity. Its range was the same thing from 0 to infinity because the square root keeps going up and it keeps going to the right forever. And the cube root, that keeps going up to the right and it keeps getting smaller going down to the left. It doesn't level off, it doesn't straighten out. It keeps growing to the right and keeps sinking to the left. Absolute value is a V-shape, goes on forever in both directions. So our domain is all real numbers, but the range is only from 0 to infinity because you can't get negative outputs. And the reciprocal function, where our domain and range were everything except for 0. So we had to kind of write it in two different parts for our domain and range. All right, I'm much more concerned about those than the others, even though I showed those others to you. So any questions on any of those before we move on?